Okay, this is a video that shows how to find the molarity of a solution by reacting it with a precipitating agent that will make it precipitate. And by analyzing the mass of the precipitate, you can figure out the molarity of the solution that you reacted with it. So this is kind of like a gravimetric analysis type of problem. So the first thing that you're going to want to do is to write a balanced equation. And so to write a balanced equation, we have iron 3 chloride, so that's going to be FeCl3. That's going to be aqueous plus, let's see, ammonium sulfide. So that's going to be ammonium is +1 and sulfide is -2, so we're going to need 2 ammoniums. Now, so the ammonium sulfide will be your precipitating agent. And what you're going to get is you're going to get ammonium chloride, which is +1, -1, and iron 3 is going to go with the sulfur and make Fe2S3. Okay, then you would need to balance that equation. So let's see, we got 2 irons here, so we'll have to put a 2 here. That gives me 6 chlorides, so we're going to have to put a 6 here and a 3 over here. And so 6 ammonium, 6 ammoniums, 3 sulfides, 3 sulfides. Okay, everything is balanced. And your precipitate over here is going to be, this will be a solid here, and then this is going to be aqueous here. All right, so this is your precipitate. And it's telling us that we're getting 0.83 grams of that. Okay, now to get a molarity of the iron 3 chloride, that's what we're looking for. So we're looking for the molarity of that. Okay, now we got to remember that the molarity is going to equal the moles of the iron 3 chloride divided by the liters. Well, we already know how much we reacted. We did it with excess of the precipitating agent ammonium sulfide. So we know that to get the molarity, what we're going to do is we're going to have to calculate the moles, but we know the liters. If we just convert the liters or the milliliters to liters, is going to be 0.0250 liters. All right, I just converted the milliliters up here to liters. Now what we got to do is we got to take this grams of the iron 3 sulfide and change it to moles, and then figure out how many moles of iron 3 chloride would be present there. So what I'm going to do is I'm just going to start off with the grams of the precipitate, 0.83 grams of Fe2S3. I'm going to look up the molar mass or find the molar mass of that. And so 1 mole of Fe2S3, if you do the molar mass, it equals about 207.9 grams of Fe2S3 if you round just a little bit. Okay, and then I'm going to do, that would give me the moles of Fe2S3, but I need the moles of FeCl3, iron 3 chloride, so I'm going to do the mole ratio. The mole ratio is 1 mole of Fe2S3 to 2 moles FeCl3. And if I do all that math, I end up getting 0.0080 moles of iron 3 chloride. If I follow I got 2 significant digits here, so I do 1, 2 there. Okay, so now I know the moles of iron 3 chloride. Now I just need to plug that in right here. So I'm going to take that number and plug it in right here, 0.0080 moles. And then that will give me the molarity, moles per liter. And so if I do that math, I end up getting about 0.32, 2 significant digits, molar. That's the answer. Okay, that's it on that one. So I hope you can figure that one out. Okay, so that's it.